Good afternoon.
Good afternoon.
Thank you. It's good to see that nobody's sleeping after lunch. Right, what I want to talk to you today is about cloud infrastructure. I'm a very simple guy. I do practical, hands-on stuff. So, what I want to look at today is how do we build, operate very large-scale cloud infrastructure. The infrastructure that is then necessary to enable lots of other applications, whether they are applications in science, applications in enterprise, applications in startups that you're going to build to serve your clients within Morocco, out of Morocco. A little bit about Sardina systems. We focus on cloud data center infrastructure automation. So, within this space, from our point of view, cloud infrastructure, how is it different from operating traditional data centers? The answer is, it's different. And at the same time, it isn't. Because one key thing here is flexibility. That is what makes cloud data centers very different from traditional facility. Where we have unique technologies that gets us the ability to pack VMs very, very densely like sardines. That's the reason behind the name Sardina systems. So it's very interesting for me to look at other folks who are interested in building companies, driving innovation. The group of us that started a company, that's what we've always been. We build companies. Some of us are a little bit younger than others. The younger ones have 10 plus years experience building big, massive machines. The older ones are a little bit older. The background of the team has mainly in large supercomputers. Previously, we're dealing with folks who do weather forecasting. 1 in 3 of top-tier global weather forecast facilities use our products before. And that business, it is not acceptable to get Monday's weather forecast on Tuesday. And what happens if you mess up? In that situation, well, in some countries, weather forecasting is not a civilian business. It's a military business. So if you mess up, soldiers come back in body bags. Very simple. Today, we deploy brain cells to solve problems in automating infrastructure. And we'll come to that in more detail. Now, first, cloud facts and myths. Lots of people say cloud, it's slow. Is it? Not really. When your overhead from virtualization is sub 10%, very few applications today are pushing performance exceeding 90% of peak chip performance. If you're pushing performance exceeding 90% of peak chip, then yes, this is a problem. Second, people talk about virtualized systems are not efficient, they are not cost effective. That's complete nonsense. Depends on how you run it. Depends on how efficiently you can operate the facility. And some other people say, well, it's better to run on physical machines. I know the machine, I know where's the machine, and I can manage the machine. Is it? Not really. What happens when you're 90 days into when you're 99 days into a 100-day job and the machine failed? What are you going to do? Start from day one? That's what you have to do if you're running physical machines. Virtualized, I can keep the computations going, migrate the workload away. It may not finish in 100 days. It may finish in 101, but you're not starting from day one again. Then there's next question of, well, I have no idea where the data actually sits. Is it? Not really. Not if the facility is actually in country. Then you know that you have control over data sovereignty. And first, I want to make a distinct difference between two roles in the cloud. The service provider and the service consumer. Service provider, his concern is only at providing virtualized environment, whether it's compute, storage, network. And the service provider is responsible to ensure that whichever way he does it, that the virtualized environment isn't going to be impacted. This service provider doesn't care at all what you actually do inside a VM. As far as he's concerned, a VM is provided, end of story. Now, on the other hand, a service consumer says, I don't care about the actual physical hardware. I just want a compute environment. Get me a compute environment. You deal with where it actually sits. And the VM user is responsible and is concerned only with the application inside the VM. So, what can you do with in-country cloud infrastructure? It makes very, very easy to build cloud-first applications. It makes very easy to drive technical innovation, business innovation. And now, not only that you have a usability benefit of having an in-country cloud, because in-country means proximity between you and the actual machine where the VM is sitting on will be much closer. Now, I don't care about what anybody else tells you about, well, it doesn't really matter where the VM lies, but there's this thing that I still haven't figured out how to refute it. It's called speed of light. Speed of light says, well, the maximum that you can transmit data is the speed of light, signal. So proximity is a good thing. And from a national development point of view, it is good to have an in-country cloud. Why? Because you stop or you minimize the outflow of capital from the country. It's very simple. You're not paying somebody else. So, we talked about Spark this morning. From a facility operator's point of view, Spark is workload sitting inside a VM. What do you use Spark for? If I'm an operator, I don't care. Now, let's look at a different angle. The world's largest restaurant, 5,000 seats, 300 chefs, 1,000 employees. In a week, these guys consume a ton of chili peppers and 3 tons of fish. Interesting. But It's in China. And it can only be in China because you have a huge available workforce. This workforce just needs discipline. You need a slave driver, nothing else. And you don't need brain cells. Unfortunately, data center operation isn't the same sort of thing. Within enterprise, a typical ratio at the peak of ratio of servers to sysadmin tops out about 100 servers to 1. If anybody tells me that he or she can manage by hand more than 100 physical servers, I've got loads of people who want to employ this guy and want to meet this person, because in 20 years of operating machines, I've never met anybody like that. SuperNAP, one of the large facilities in the US. 250 megawatt facility, housing max 280,000 physicals. Now, you may see that I'm referring to physicals versus virtuals. It's a distinct difference because from an operation standpoint, our concern is physical servers. So we look back, 100 servers per sysadmin. So if I have 280,000 physicals, that's a problem, isn't it? Because first, in data centers, you need skilled workforce. You need brain cells and discipline. And that doesn't come easily, and that doesn't come cheap. And the bigger problem actually is, at this scale, 280,000 divided by 100, 2,800. Geez, what, you're going to have a village full of sysadmins to run a facility? Good luck. Can't work. At large scale, there are 3 important things that you need to remember when it comes to operations. Automation, automation, automation. So how do we do it? Well, in a traditional situation, you've got a operations manager who is tasked to figure out how to manage bottlenecks within a facility. Facilities will have bottlenecks. It's a question of how do you manage it. It is virtually impossible to build facilities without bottlenecks. And then you also have this problem of, well, you've got a new workload coming in. If you have 280,000 physicals, where on earth are you going to place this new workload? That's a hard problem. And workload within facilities change. Say, for example, you've got a VM that is running some applications that, say, for example, serving e-commerce. People tend not to shop at 3 o'clock in the morning. But people tend to shop at 7 o'clock in the evening. So right there and then, there's variation in workload. If you're an operations guy, what are you going to do with this kind of variation? And if you say that, hey, I'm just going to load up huge volumes of servers just to meet the what if situation, your cost goes through the roof. And your customers is demanding rock bottom price. Problem. And the next problem that you have is that you're going to run basically villages full of sysadmins doing monkey job. Is it the best thing to do with brain cells? Probably not. So as I mentioned, your OPEX and your CAPEX, your operations expense and your capital expense is going to be crazily high. Conversely, automate the hell out of it, get the problem out. Sort workload placement, sort out bottleneck problems, sort out data center rebalancing. You can do this in an automated manner today. And with that, you drive your OPEX and the CAPEX down. This is what we do. We take you from worry to zen. So let's look a little bit deeper into cost. Top 3 data center cost items: hardware acquisition cost, energy OPEX, and facilities CAPEX. Facilities CAPEX and energy OPEX their relative positions may change depending where you are, basically depending on cost of land, cost of your facility versus cost of energy. Operating at scale is not the same sort of thing that you get kids to go and play with bits of servers. And here, operation scalability is key. How do you scale up? Now, before I go on, have to say that if one were to say that, hey, I'm going to try building a system that will work on 2 servers, prove that it works, and then I'll run it on 10. It still works. I'll run on 100. It works, great, I'll live with that. What's the problem? The problem is, what happens when you scale up to 1,000? Now, some people will say, well, at 1,000, I'm just going to break down. If it doesn't work at 1,000, I'm just going to break down 1,000 into 10 lots of 100, and I manage it that way. Guess what? Now you scale it up to 100,000, what are you going to have? You're now not going to have one single facility. You're going to have 1,000 management entities. You'll be pulling your hair out. Ultimately, this is a business of doing something, question of what do you do with what you have? Now, first, reservation is what you requested. It is easy to get reservation up. It's trivial. Utilization is what you actually use. Getting utilization up, that's non-trivial. Now, at some of the larger sites, utilization is at 30%. Reservation is well above 80%. And at some of the other large sites, well-known statistics, Amazon at 7 to 15% utilization. Very, very, very low. So now, let me contextualize that. Would anybody leave lights at home for an entire week if they're home for 1 day? Probably not. That, by the way, is 15% utilization. So what do? First, we figure out how to optimally place an incoming workload within a large facility. And when I say a large facility, I mean having to operate the entire facility as a single management entity. And next, you've got workload that changes, as I mentioned earlier. Now you need to figure out how to rebalance that workload. That is one massive jigsaw puzzle problem. Now, let me go into a little bit more detail. For us, before you make any decision, you need to collect data. So, what sort of data? Well, the headlines are CPU, memory, disk, and network. First-year computer science kids will know that. So does it mean that you go out and collect 4 metrics? And is CPU equivalent to one single metric? Like running top, and you say, oh, 0.45. Yes, 45% utilized. Is it just that? No. CPU, for us, depending on the platform, works out to be between 20 to 40 metrics. And overall, within a single machine, within a machine, the whole set works out to be, again, depending on the machine, somewhere between 150 to 250 metrics. So each metric, when you're working out a jigsaw puzzle problem, is a dimension. So now, want to try solving a 200-dimension jigsaw puzzle problem? That is an interesting mathematical problem. I'm not saying that we have the best solution out there in the market. We have a solution. Can we take it further? Can we develop it further? Without a doubt. Is there anything better that can be done? For sure. Could we do it with anybody else? It'd be stupid not to. Could we partner with you to do this? Yeah. Now, I should perhaps clarify what do we mean by jigsaw puzzle problem. Now, let's assume that we have a very, very, very simple machine. This machine has one pipeline. And this machine only does, let's say, integer ops. And everything on the machine all the other resources are unlimited. This theoretical machine doesn't exist. Now, suppose we have these two of these identical machines, and we have 2 VMs, 1 VM on each. And if each one of them utilized 30% of CPU, 30 plus 30, that's under 60, that's under 100. I can therefore live migrate one VM over to the other host. I'll turn off the other machine. I've saved 50% of power for that duration of time. I'll continue monitoring till when such time that the total utilization exceeds 100. At that point, I'll power on the machine and I'll migrate back. This is what rebalancing is about. Now, let's add another degree of complexity to it. Suppose now that memory bandwidth on this machine is no longer unlimited. And let's suppose that the left VM uses 60% of memory bandwidth. The right VM uses 50% of memory bandwidth. 60 plus 50, that's over 100. So even though the CPU utilization in total is still less than 100, it is now a very bad idea for me to migrate. Because if I were to migrate, what do I get? Performance degradation. And if you do that, customers will start screaming at you. And here I'm talking about 2 dimensions. Do that at 200 odd dimensions. This is where fun begins. Now, by solving that problem, what we enable is to totally cut down the energy cost. And the inverse of that is that by being able to load a lot more jobs onto each physical host, to cater to that same workload, you need less hardware. Less hardware, smaller data center footprint. It costs less. Now we're talking money, right? And now, from an operation standpoint, you want the automation tool to be able to manage large, very large facilities. S1, no partitioning. Because even from an optimization standpoint, you want global optimal. You don't want local optimal. If you partition, the best that you can get is local optimal. And it needs to be workload independent. No, you cannot do workload sampling. There are people that talk about workload sampling. Well, we'll run the workload for some number of seconds, we'll see how it behaves, see what the resources required are, and then we'll place it accordingly. There were folks at Stanford that talked about that. But in a generic enterprise, generic country level facility, can you do profiling? Absolutely not. Because the last thing that your users want is for you to profile them. So, now, if you are an operator, business is very simple. Business has 2 tabs. Money coming in tab and money going out tab. You play the 2 tabs nicely, and magically, you're making money. Now, so if you lower cost at the same revenue level, you've just increased profits. That is what VM's packing gets you. So how much money are we talking about? If you're looking at an 11 megawatt facility running circa 55,000 physicals at 10 cents per kilowatt hour, very few places today run at 10 cents per kilowatt hour. Yearly energy bill will come to about $50 million, around about $1.2 million a month. So, if you were to raise utilization from 15% up to 45% by intelligently packing the workload, what does this mean? This means that the number of servers that you need to cater to that workload is cut by 2/3. Therefore, from an energy standpoint, it means you cut your energy bill by 2/3. 2/3 of 15 million, that's a bit of money. You buy a few dinners. What about on the infrastructure side? On the infrastructure side, and this is a model, again, 55,000 server facility, assuming that your workload is growing at 16% a year, current utilization at 15%. If you again would raise utilization from 15% to 45%, the bigger saving that you then see, the saving that you then see is huge. This set of model, a particular operator, over a period of 4 years, spent $1 billion on hardware and facilities capex. You're all smart people. You can work out what 2/3 of $1 billion really means. It'll buy you a few more dinners. So, now, in this business, therefore, in order to make decisions, the first thing that you need to solve is how to gather. The first thing that you need to solve is what's the data that you need and how to get the data. Once you figure that out, per host, and this is not genius stuff. I'm sure you can go and figure out, catalog down all the metrics that needed to make up those 4 things: CPU, memory, disk, and network. But the real trick is that once you've collected the data, say you have 200 metrics, and you're sampling per second. You've got 100,000 physicals. This is non-trivial anymore. Try to collect that amount of data, synchronize, aggregate. This is now fun stuff. And once we gather the data, we dump it in to, let's call it a data dump. And on the other side of the data dump, we then need to siphon the data back out to serve any of our decision engines. And there, we solve those 2 problems of initial placement, i.e. figuring out where to place a new workload, and we solve the next problem, which is rebalancing. And you need to do this continuously. Now, there are some situations where migration of a workload is a very, very, very bad idea. For example, if you have 2 VMs, one VM has small amounts of memory. Another VM has large amounts of memory. So, thinking in terms of memory pages, the VM with more memory will have more memory pages, and if it is active, there will be more pages that could be dirtied. I'm talking in terms of, from an operating system standpoint. And if they are dirtied, then you've got to resync the memory page. Now, all right, so suppose you've worked out which one of them has fewer pages to be dirtied, or there are fewer pages that are being dirtied at any constant periods of time. Then, the other thing is, well, how about disk writes? If the VM is doing a lot of disk I/O, it is also a very bad idea to migrate it, because disk data migration is actually a lot slower than memory page migration. Now you start to see that this is a complex, non-trivial problem. So not just working out where you can pack it, figuring out when not to move it. And there are also situations where it is bad idea to migrate. Let's say migrating 2 VMs, one from left host to the right, and migrating a VM from right host to the left. Net result is they're still running on 2 machines. Mathematically equivalent. But you've just done more work. So that's a bad idea. So these are the kinds of smarts that needs to go in to a rebalancing system. And then magically we present we hide away all these complexities and present it in that. That's a single page that we add on to the OpenStack Horizon interface for data center optimization. All the other bits that I talked about earlier is hidden behind here. Let's look at a few use cases. Now, traditional HPC. I come from a supercomputing background. So the first thing that we looked at was HPC. Right. What's the benefit for HPC?
HPC, high performance.
High performance computing. Now, by running VMs for HPC purposes, what we're enabling is that say in a research facility, to enable different user groups to have their own clusters. You're no longer confined by the old problem of, well, the sysadmin says you can have Red Hat Enterprise Linux version 6. You want anything else? No. That's what you get. With virtualized clusters, you don't have that problem anymore. Because from the operator standpoint, you will run whatever you want. And if you happen to mess up on the machine, it's very simple. One click, delete. One more click, start. You've just reimaged your machine. Simple. And from a service provider standpoint, because you can now blend different types of workload, at the organization level, you've got much higher throughput. You can run a lot more jobs within a particular point in time. Within a particular amount of time. And it also enables what I talked about earlier, auto handling of your job that's 99-day into a 100-day job and hardware fails. Disaster recovery. Now, some industries, for example, banking, they're notorious for these things. These guys will run identical copies of data center that sits idle, does absolutely nothing. It is basically glorious heater. Does nothing. It's a data center that's running, waiting for disaster to happen. Because when disaster happens, that's when they migrate workload, that's when they switch workload across to the DR copy. It's a colossal waste. So, with virtualization, what we can do is to run the two facilities as if it is one. In the event of a disaster, flush all the workload from one side to another. Yes, you will be running at degraded performance, but then the next bit comes in is that we would look at what type of workloads should be given higher priority, and then you can manage the resources that are allocated to each VM without interruption. So the VM may think that I've got equivalent of 1 gigahertz of processor and equivalent of 1 gig of RAM. But from the host point of view, we've put a cap on it. So we could cap it at, let's say, 100 megahertz. The VM isn't going to know. And we kept memory at, let's say, 100 megabytes. Again, the VM isn't going to know. The VM thinks it's got 1 gig of RAM. And by doing it this way, everything can be automated. You don't need to train sysadmin monkeys. Which means there's zero probability of human intervention caused failure. What about application hosting? And this is the classic web host problem. Here, web hosts are squeezed by customers saying, I want cheaper compute. I don't care what it is, I want cheaper compute. So if you're a hosting provider, what are you going to do? You're going to cut your margins. The only way for you to keep your margins up and the only way for you to increase your margin is to drop your operations cost. That's what it does. ELINT, electronic intelligence. Here, sometimes you get facilities that are built for peak load, a defined peak load. And which basically means part of the time it's sitting doing nothing. Glorious heater. So the machine is underutilized, costly, and when you have a disaster, some terrorist strike, what are you going to do? Now, if you're running a conventional facility, you're locked in. You've got no flexibility. If you have a job that's been running, some resources that's been previously allocated, you've got no flexibility to reallocate the resources. With a virtualized facility, what we do is to enable you to dynamically manage these resources. Weather forecasting. Now, weather forecasting facilities, typically they run two types of workload. They run the time-critical workload and the less time-critical workload. So, time-critical workload are, for example, the evening television weather forecast. You can't say, you can't get the TV station to go on TV and say, guys, weather forecast is delayed tonight, yeah? Tune back at 9 o'clock. That's not acceptable. So what needs to be done is to be able to dynamically manage the resources so that when you have a time-critical job that comes through, that's given priority without interruption to the existing running workload. That's key. Academic research. The conventional way is very static. Now, conventional way also costs you a lot of money for machines that sits there, again, doing nothing. By running a virtualized facility, what we can do is to enable an academic facility to dynamically provide the compute capabilities on demand, even high flux demands, so very fast changing demands. And this overall enables the researcher to focus on doing research, not on machine operation. So you're not getting your student to go run around doing monkey jobs. What do we do then? Well, we take you from the left to the right, from worry to Zen. What sort of resources does it need? Now, if you run it, if you have developed the software, keeping resources low, we can start very small. A typical customer proof of concept facility would have 4 to 5 physicals. To run our software, to manage 10,000 plus servers with full resilience, you need about 20 physicals. The actual sizing is typically something that we would do with a client. So now, for a client, what we can do also is to build, operate, and transfer a facility. What does this mean? Well, first off, in any country, capabilities do not grow on trees. Brain cells do not grow on trees. Brain cells, capabilities are developed. And we can do that. The entire way from concept of, I want a facility, tell me what I need, working out the requirements of, well, to meet X workload, you need Y number of servers, you need Z amount of cooling, you need whatever other networking kit, the whole shebang from I want a facility to facility up and running, manage for you, and then take you from the beginnings of operation through to the end, whereby the entire operation is then managed in country. Sometimes the way that I describe it is that we are mercenaries, IT mercenaries, but we do not bring in an army to fight your war. We bring in the generals, and you bring in the privates. And we'll build up the capabilities of the younger soldiers, and as they grow, rise up so that they no longer need the generals that we bring in. And we do this in country, which is what not every provider in the market does. That's it. Thank you, folks.